Good afternoon, and welcome to our monthly uh, virtual meeting of the Naval Order of the United States Continental Commandery. We have a great program ahead of us. We have a special guest, Dr. Frank Blazich Jr. He's come to us from the American History Museum of the Smithsonian Institute. He's going to talk today about a very interesting subject, which is related to the Navy lighterage pontoon system that was used during World War II. He'll give kind of the history of that and a little bit of background of how it was used. For those that are joining us, some of you have maybe joined us before, but we might have a few new people with us. And one thing that I just wanted to put out there is a little bit of background on the Naval Order. The Naval Order was first established on the 4th of July, 1890. A group of people had gotten together up in Boston, and they basically wanted to create an organization that had eligibility based on the membership that had to do with your service in either the Navy or the Marine Corps, or even from the Revenue Service or the privateer services. It's unique because it's the oldest American hereditary exclusively naval society. And it's dedicated interest in naval history, encouraging its records and also its preservation. So provision for membership is based upon lineal descent, ensuring strong continuing interest in the deeds and accomplishments of the forebears in perpetuity. Some of our main missions is to commemorate American Sea Service heroes and important historical events. We support the study of naval history through writing, speaking, and educational events. And we preserve the Sea Service historical artifacts, documents, and monuments. And we also promote camaraderie among our companions. And this being a virtual companion organization, we get together on events like this and through emails and through our newsletters and our website. But we also have annually our annual meeting where we can see each other face to face, and other local commanderies can meet for lunches and dinners and speaking engagements. So thanks for joining. Just to give a little bit of background on our guest speaker. So Frank Blazich, Dr. Blazich, he's the curator of military history in the Division of Political and Military History at the National Museum of American History as part of the Smithsonian Institution. He's a native of Raleigh, North Carolina, and he specializes in American military experience in the 20th century. He's a veteran of the U.S. Air Force, and he holds a doctorate in modern American history from the Ohio State University. Following his doctoral studies, he served as the historian at the U.S. Navy Sea Museum in Port Hueneme, California, before he moved to Washington, D.C. to serve as the historian at the History and Archives Division of the Naval History and Heritage Command. And so from June to December 2016 in that role. In January of 2017, he assumed his current position as the curator of modern history at the Smithsonian's National Museum of the American History. He's edited his first book, which is called The Baton Survivor. So you might want to look into that. And that was published in February 2017. And he's just recently worked on another book project, which was called, or is called, An Honorable Place in American Air Power, which is about the Civil Air Patrol coastal patrol operations from 1943 to 1945, and that's slated for publication in late 2020. So we're really excited to have him with us. Please note that we'll be going through a presentation talking about all of the highlights, and then we'll have an opportunity through our chat in our comment box to have direct questions that he'll be able to answer later. So once again, thanks for joining. And thanks very much for the opportunity to meet and to talk and to hear about this great subject. So over to you, Frank.
Well, thank you very much for the very kind introduction. I want to say good afternoon, ladies and gentlemen. I thank you all for having me here today, and I hope this subject will be of some interest. It's something I first learned about in fall of 2013, and by a twist of fate became reacquainted with in 2017. It's a small world after all. Technology alone does not produce victory in war, but rather must be integrated into a complex blend of doctrine, leadership, and operational art. In his best-selling book, Engineers of Victory, Historian Paul Kennedy explores the middle level of grand strategy, the area of practical implementation of policy which is often taken for granted. Kennedy notes that scholars, quote, rarely inquire deeply into the mechanics and dynamics of strategic success and failure, yet it is a very important realm of inquiry, though still rather neglected. This talk will try and explore the middle level of Operation Husky and Operation Overlord, and an unsung critical element in the logistical effort to supply and out-equip the adversary, U.S. Navy landing pontoons. This is a story of American invention, British innovation, and ultimately Allied achievement. The brainchild behind the Navy landing pontoon was Massachusetts native John Noble Laycock, seen here on the left. Born on May 18, 1892, he received an appointment to the U.S. Naval Academy in 1910. Classmates then described him as, quote, congenial beyond congeniality and naturally brilliant. After graduating in 1914, he successfully submitted a request the following year to transfer to the Civil Engineer Corps. He enrolled in Rensselaer Polytechnic Institute in Troy, New York for postgraduate instruction, and he graduated in 1917 with a Bachelor's of Science in Civil Engineering, and in June, formally transferred from the line to the Civil Engineer Corps. Now, the Navy would send Laycock on a variety of assignments in the United States, the Canal Zone, and Haiti. In mid-March 1939, he accepted an offer from Rear Admiral Ben Morrell, Chief of the Bureau of Yards and Docks, or BUDOCS, to transfer to Washington to become the War Plans Officer tasked with reviewing and preparing all of the Bureau's sections of the Navy's various war plans. Foremost among these was War Plan Orange, conceived in the event of war between the United States and the Japanese Empire. Broadly delineated in 3 phases, the geographic scale of the Pacific proved the most troublesome for planners and strategists who recognized the need to seize and develop advanced bases to resupply and repair the fleet and secure logistical and communication lines. A focused War Plan Orange began to coalesce in the 1930s, and the Naval War Plans Division, in turn, reached out to BUDOCS to leverage its intellectual resources for the development of advanced fixed and mobile bases. BUDOCS established a War Plan section to contribute its component to War Plan Orange, and the Bureau confronted an array of unresolved questions ranging from personnel to technologies to solve the primary issue, building a naval base in a remote, undeveloped location. As early as 1932, the Bureau began contemplating the use of standardized pontoon units for the advanced bases. Fast forward to 1936, when Lieutenant Commander Paul W. Haynes of the Construction Corps found himself assigned as the superintending constructor at the Union Iron Works in San Francisco. While in the construction yard, Haynes noticed the assembly of a sectional steel pontoon barge for use in supporting a gold dredge, which you can see before you here. And he in turn provided BUDOCS with a drawing of how he believed steel box sections could be connected to form a barge. His design used 10 by 20 by 6 foot steel boxes, joined together with heavy bolts installed by men climbing inside the individual pontoons, and then passing the bolts between them. In summer of '39, Laycock turned his attention to the installation and assembly of advanced bases. And while examining the various pontoon records and BUDOCS files, he located and studied Haynes's sketch for these sectional pontoons, and he found 2 primary faults with the proposal, mainly the dangerous bolting procedure and the inadequate strength of the finished assembly. Around July 1940, Laycock decided to build a model for experimentation. Using a supply of empty cigar boxes, he evenly spaced the boxes and linked them together in a string with wood model kite sticks fastened to the corners of the boxes with small nuts and screws. The model demonstrated the feasibility of connecting individual pontoons using continuous angles to create a well-diaphragmed sectional box girder. In August, Laycock met with the Dravo Contracting Company of Pittsburgh to discuss the remaining problems of fastening and assembling. He left the meeting expecting to receive a proposal to address these matters in the coming weeks. What you see before you is the original Laycock model. This sat in the Smithsonian for 50 years, and nobody knew what it was. And I direct your attention to the photograph on the right, and look at the red arrow. There is that exact model. So a week after Laycock lost patience, and he finally figured, I can solve this problem myself. Meanwhile, during his family vacation, much to the chagrin of his wife. So for a month, he chewed through the problems, in Laycock's own words, working, quote, in pretty much of a trance. His mind returned to his cigar box model and the wood sticks. Use of continuous steel angles in place of the wood sticks would be able to carry the major tension and compression stresses for the assembling pontoon string. With a continuous angle, the primary strong point in the assembly, the actual connecting fasteners could thus be relatively light. And to form the continuous angles between the steel angle piece and each individual pontoon box, Laycock needed room for his fasteners. He therefore opted to cut away the corners of the pontoons, cover the triangular opening with steel plate, and then weld on a connecting angle strap with holes to enable assembly of the individual boxes to those continuous angles. For a cigar box model, Laycock had opted to use small screws, nuts, and washers to connect the boxes and the wood angles. For the steel pontoons, Laycock scaled up the screw into a 1.5-inch steel assembly bolt that could be inserted by hand and tightened to a nut welded to the connecting angle strap on the pontoon corners. To compensate for unequal tightening of all of the bolts in a pontoon assembly, Laycock used one set of bolts to directly connect the angles to the pontoons, and a second arrangement of specialized connections involving a wedge bolt, diagonal wedge, and a wheel nut that you can see there in the lower left that could be installed by hand without any specialized tools. With the fastenings worked out, Laycock next needed to determine the criteria for the physical dimensions of the pontoons. 7 criteria would factor into the final dimensions, and I've listed all 7 of these criteria on the slide before you. By October of 1940, through trial and error, Laycock determined that the ideal pontoon dimensions would produce a box measuring 5 feet by 7 by 5 feet. Laycock and fellow Budox employees finalized the design of the fasteners, which are often referred to as jewelry, required to connect the pontoons to the continuous steel angles. With the models and designs for the pontoons and jewelry complete by December of 1940, Budox finalized blueprints for the pontoons and entered into a contract with the Pittsburgh Des Moines Steel Company on February 18, 1941, to fabricate a number of pontoon units for testing and evaluation. 2 pontoon designs were assembled, the 5 by 7 by 5 foot T6 box and the 5 by 5 by 7 T7, which had a curved section at one end for use as a prow on barges. Now, after its retreat from Western Europe in June of 1940, the British Chiefs of Staff stood up what became known as Combined Operations Headquarters. This new joint air-sea-land organization would create the commandos and plan, train, and direct offensive operations against enemy-occupied territories. Within the new command was a development center tasked with examining and experimenting with craft and equipment for combined operations. By summer of 1941, its commandant, Captain Thomas A. Hussey, senior on the left and right, received new instructions to investigate problems likely to be encountered with large-scale amphibious operations in Europe, particularly in the landing of vehicles and supplies. Foremost of these was one problem: bridging the gap from ship to shore. Now, from November to December 1941, Hussey led an Admiralty delegation to Washington to share and discuss designs for 3 amphibious assault craft. These were the LST, the LCT, and the LSD. Now, during a free week prior to the attack on Pearl Harbor, Hussey went to Narragansett Bay, Rhode Island, where he first learned of Budock's new pontoons. Impressed with the equipment, he reported the technology to Combined Operations leadership upon his return in January of 1942. The British saw utility for the pontoons in certain circumstances, primarily in the construction of jetties for landing small vessels in the absence of port facilities. But beyond acquiring photographs and accounts of the pontoons, no actual experimentation occurred. Now, on May 30th, 1942, Prime Minister Winston Churchill wrote to the Chief of Combined Operations a small note regarding piers for use on flat beaches. The short message read, "They must float up and down with the tide," adding, "Let me have the best solution worked out. Don't argue the matter. The difficulties will argue for themselves." Now, a Combined Operations report of June of 42 concluded, quote, "As it is not possible to guarantee the seizure of a port in good condition for handling cargo, plans for combined operations have to be based on the assumption that supply will have to be effected over beaches." Now, a week prior to Operation Jubilee, the ill-fated landing in Dieppe, France, Combined Operations Liaison Officer in Washington reported developments with the Navy's landing pontoons, reporting how he was, quote, impressed with the ease with which these pontoons can be shipped and assembled wherever required, and feel that as lighters or other assemblies, they would be valuable for many landing operations. So in November of 1942, following the successful Allied landings in North Africa, known as Operation Torch, Hussey, who was now the director of experiments and staff requirements, learned of planning for the next operation, the invasion of Sicily, codenamed Husky. Hussey's examination of sounding charts of the island revealed gently sloping seafloors for all of the planned invasion beaches. These gentle slopes would cause the LSTs to ground 500 feet from shoreline in water 6 feet deep. Now, waterproofed vehicles could only safely wade ashore beginning from no farther than 300 feet out from the beach. Alarmed, Hussey brought the issue before the Chief of Combined Operations, Commodore Louis Mountbatten, who recommended that the captain assemble a team of technical experts to find a solution. Following discussion in mid-December between the best amphibious technical experts at Combined Operations, the only known option involved use of the U.S. Army Corps of Engineers Treadway Bridge, which was used in the North Africa landings in November. But even with the Treadway Bridge, no known option could be found to surmount a foreseen 350-foot gap between the beach and the LSTs. Hussey chewed over the problem until he came upon a novel solution. On February 21, 1943, he presented Mountbatten with the idea of a floating, prefabricated roadway or causeway using the American pontoons. These, he explained, could be towed behind the LSTs to the invasion beaches until positioned so that forward momentum drove the causeways ashore. Once in place, these causeways could be secured to the LST ramp so vehicles could drive off the ship and up to the beach in the dry. Now, while some of Mountbatten's staff doubted the idea, the Commodore saw the viability of Hussey's proposal. He immediately ordered the captain to Washington to press for construction of a prototype and hold operational trials between the Treadway Bridge and the Navy pontoon causeway. Mountbatten wired Husky's overall commander, General Dwight D. Eisenhower, to explain the problem of the beach slopes and the critical importance of Hussey's mission. The matter required expediency if all the necessary equipment were to arrive in time for the planned D-Day of 10 July. Arriving in Washington on March 4th, Hussey found no effort underway for conducting trials. Undaunted, the British captain managed to convince senior American leaders to support a trial. He connected with Laycock and explained his idea for a massive 350-foot-long pontoon barge to bridge the ship-to-shore gap. But time and existing pontoon material, however, made this barge impractical, as the present maximum length of a pontoon string measured 105 feet. But recognizing the difficulties of handling four 105-foot barges together in rough seas, Laycock considered this ill-advised and an impossible seamanship problem. Instead, he proffered for a compromise and designed a 175-foot-long causeway composed of 2 pontoons wide by 30 pontoons in length. By using 2 of these structures and overlapping them in a manner akin to a slide rule, a maximum length of 325 feet could be safely constructed to bridge the gap. On 18 March, Hussey's trial commenced. The first LST approached the shore carrying 2 M7 105mm self-propelled howitzers while towing 2 175-foot pontoon causeway sections. Just prior to the LST grounding, the causeway crew of 20 Seabees, 1 warrant officer, and 1 Civil Engineer Corps officer allowed the ship's forward momentum to drive the causeway sections up on the beach. Within 8 minutes, the Seabees maneuvered the overlapped causeway into alignment with the LST bow ramp, flooded the individual pontoons, and anchored the causeway on the seafloor. The first M7 idled on the beach 16.5 minutes after the LST had grounded. For the next trial, the other LST came ashore and grounded. 4 officers and 36 soldiers from the Army Corps of Engineers began to unload the Treadway Bridge and assemble the structure until 360 feet linked the LST to shore. After 45 minutes, the 2 M7s from the first test drove over the Treadway Bridge and into the LST. The demonstration convinced senior planners that amphibious landings could work with the naval landing pontoons, and the following day, the Navy Department agreed to supply the equipment for the Sicilian invasion. And so, in the early morning hours of 10 July 1943, the amphibious invasion of Sicily commenced. 10 LSTs side-carried causeways, while six more causeways were towed to the assault beaches for the U.S. 7th Army landing along the Gulf of Gala. All arrived without incident, each manned by a platoon of 2 officers and 34 enlisted men drawn from the 54th Naval Construction Battalion, NCB, as well as Construction Battalion Detachment 1005 and 1006. Despite 5-foot seas, which compounded problems aligning the causeways with the LSTs, as well as attacks by the Luftwaffe, the pontoons worked brilliantly. In 23 days of round-the-clock shifts, the Seabees unloaded over 10,000 vehicles using the causeways. When British General Sir Bernard Montgomery stepped from his landing craft onto a causeway, Mountbatten remarked, quote, "The general is not setting foot on Sicily. He is setting foot on one of these miraculous American pontoons." The next month, at the Inter-Allied Conference held in Quebec, civilian and military leaders approved an outline plan for a cross-channel invasion for the coast of Normandy, France, codenamed Overlord. Overcoming Overlord's logistical hurdles warranted creative solutions. Recognizing the need for port facilities, but also the challenge of seizing the port at Cherbourg, British planners hatched upon the scheme of building artificial harbors, codenamed mulberries, able to discharge approximately 6,000 tons daily. 2 harbors, Mulberry A off the American beach Omaha near Saint-Laurent-sur-Mer, and Mulberry B off the British Gold Beach near Arromanches, were planned to provide sheltered water by D+4 and be fully established by D+14. Both would be designed to last for 90 days. Before then, the planners envisioned Omaha and Utah beaches handling 10,200 tons of supplies and 5,700 tons of supplies daily by D+10, respectively. But as with Sicily, coastal geography complicated landing supplies on the beaches. The Bay of the Seine featured flat sandy beaches with slopes varying from 1 to 150 feet and a tidal range of 21 feet, with a high water duration of 3 hours and a tidal current of 3 knots. So at low tide, with water at a depth of 12 to 18 feet, a ship would find itself grounded over half a mile from shore. Liberty ships requiring water depths of at least 28 feet would find themselves grounding out 4,000 feet from shore. Now, LSTs seemed the logical choice to land supplies, but the Normandy tidal range, coupled with long, flat beaches, risked valuable ships being stranded and dried out for hours, thus becoming a new type of LST, the large stationary target, vulnerable to enemy artillery or air attack. But even before the landings at Sicily, Allied planners began to articulate the specifics for a shallow draft pontoon craft able to ferry the entire deck load of an LST from ship to beach on its first trip. Throughout July and into August, Budoc's personnel experimented with larger barges. The pontoon causeways developed for Sicily proved to be, quote, the universal solution. Laycock merged 3 causeways together to create a 6x30 pontoon barge, measuring 175 feet long by 42 feet wide. This barge could move 300 tons of cargo, carry 30 to 40 vehicles, and was large enough to unload an entire LST in only 2 trips. Now, to mate with an LST, the Seabees fitted the barge with a large 60-ton ramp and 2 massive outboard motors to propel the barge at a leisurely 2 to 3 knots. Tests in Davisville, Rhode Island commenced from the 14th to the 31st of August 1943 with a prototype barge which demonstrated its feasibility, albeit in need of refinement. And the photographs you see here, as far as I can tell, are of the actual tests from August of 43. Now, the 6x30 foot barge proved the most suitable size for operation, and it could actually be towed at 8.6 knots from an LST. An experienced barge crew required only 15 minutes to moor the barge to the bow ramp of an LST in the open sea, but 10 32-ton medium tanks were able to be loaded in less than 5 minutes in one test. Now, during the tests of the prototype, a naval aviator flying overhead spied the barge with its pontoon protrusion on its stern and this narrow ramp end on the bow. And bemused, the aviator referred to the contraption as resembling a rhinoceros, and the Rhino Ferry was thus christened. Even the British, who early on referred to this barge as a Phoebe ferry, acquiesced to the somewhat less elegant American moniker. Now, the initial pontoon requirements for Overlord dwarfed any previous use of this equipment. Between August and September of 43, Overlord planners estimated requirements for 56 causeway sections, together with 11 475-ton capacity floating dry docks, 55 Rhino ferries, 53 by 7 Rhino tugs, and this came out to right at just under 21,000 pontoons. So desperate was the need that the Royal Engineers broke up 5 pontoon dry docks in the Mediterranean just to ship this material back to the UK for construction for the Overlord structures. Now, the Rhinos would be divided up with 28 to the British, manned by the British Army, for use on Gold, Juno, and Sword beaches, with the other 27 Rhinos allocated to the Americans for Utah and Omaha beaches, and these would be manned by Seabees of the Navy. In March of 1944, the Supreme Headquarters Allied Expeditionary Force, or SHAEF, requested an additional 20 Rhinos, and this would provide 10 Rhinos for the British and American beaches apiece in the event of wastage or loss due to weather. Now, with the basic design for the Rhino approved, efforts to refine the design shifted from Rhode Island to Falmouth, England. Seabees of the 81st Naval Construction Battalion started assembling pontoon strings, and Rhino Ferry No. 1 was launched on December 7, 1943. The Navy's premier pontoon personnel, CBD 1006, arrived in England from the Mediterranean to refine the ferry into a craft suitable for the Overlord invasion. Tests and trial operations with the ferry in late December 43 and into early January 44 found fault with several design aspects, resulting in a few changes, producing a final design which can be seen here on the right. Notably, the larger 60-ton ramp, and you can see one of those ramps on the lower left there, was replaced with what are referred to as the wood and steel Olsen ramps, and also 2 inverted scow pontoons. And you can see the Olsen ramps at the upper right hand there of the photograph. 2 outboard engines were also fitted to the outermost stern pontoons to propel and drive the barge, along with plastic armor around both the engines to protect the mechanism and the operator from bomb or shell splinters. I should mention that the Olsen ramp was designed and named in honor of Lieutenant Carl M. Olsen of the Civil Engineer Corps. A member of CBD 1006, he was killed at the landings at Salerno and was the first U.S. Navy officer killed during the land invasion of continental Europe. Now, crews for the American Rhino ferries came from among the 28th, 81st, and 111th Naval Construction Battalions. Due to the priority placed on pontoon assembly, however, most of the crews received only 2 or 3 days of training on the ferries on the relatively quiet waters at Dartmouth. And as I mentioned previously, and this was after considerable discussion, members of the British Army would actually man and control the Rhino ferries for the British invasion beaches, not personnel of the Royal Navy. As work progressed on the Rhinos, engineers at SHAEF also requested installation of pontoon causeways on the invasion beaches for ship-to-shore offloading until the Mulberry harbors were operational. Now, from conception, Laycock's pontoons had incorporated fittings so to flood and drain the boxes for use in sectional dry docks. So the Normandy causeways would actually be sunk in place, extending from the high water line to just beyond the line of minimum low water. Each of the American invasion beaches would have 2 of these causeways installed to serve smaller vessels, predominantly the landing craft tank, or LCT, and there would also be 2 causeways each for Gold and Juno beaches, with 1 allocated for Sword Beach. To support the LCT and smaller craft and unloading, engineers mounted 4x12 pontoon blisters to the causeway, spaced intermittently from 250 to 350 feet apart along both sides of the causeway. And I don't know if the red arrow is showing up there, but it's pointing to one of those blisters. This arrangement ensured that 1 blister would always be available for unloading LCTs regardless of tidal conditions. And again, the causeway pioneers of Sicily and Salerno, CBD 1006, would assemble and man the American causeways, which would allow unwaterproof vehicles and men to come ashore with dry heels and feet 24 hours a day. Engineers from the 15th Kent GHQ Troop Engineers of the British Army would man, construct, and maintain the British causeways. Prior to H-Hour on D-Day, 5 LSTs arrived off Omaha and Utah Beach towing Rhino ferries. Now, heavy seas with 6-foot wave crests complicated the marriage process between ship and barge, but eventually all but 1 ferry at Utah managed to load up and begin the slow journey to shore. Now, combat conditions on the invasion beaches affected these initial Rhino landings. At Omaha, the ferries received orders to stand off until beach obstacles were cleared, a tall order considering the horrible losses to the Gap assault teams of the Army Combat Engineers and Navy Combat Demolition Units. One Rhino missed this standoff order and managed to reach shore at noon, beaching itself in a gap between the obstacles, where it ended up remaining in place for the remainder of the day. At Utah Beach, the assault forces fortuitously landed half a mile south of their objectives in an area of weaker German defenses, and the 4 Rhinos began landing in the afternoon, and by midnight they had collectively unloaded 175 vehicles. For the Royal Navy, the tow of Rhinos across the channel went a bit less smoothly. Force S, Force J, and Force G each lost a Rhino ferry, while 17 out of 39 Rhino tugs also broke free and were lost. Unloading of LSTs also went poorly, in part to the weather making the marrying of the ferry with the ships near impossible, as well as the state of the beaches themselves. But here the issue was both German beach obstacles, as well as, quite frankly, a complete lack of organization required to efficiently unload the Rhinos. The German beach obstacles took a toll on the Rhinos, and quite frequently teller mines knocked out multiple ferries while they were retracting from the beaches, and this just at Juno Beach alone. On June 7th, with the beaches secure, the surviving Allied Rhino force expanded its operations. 6 additional Rhinos arrived at Utah in the early hours, and all 11 operated throughout the day, despite enemy artillery fire and air attacks. 15 additional Rhinos arrived at Omaha, and those held offshore on June 6 began landing and discharging cargoes of varying mass. 1 Rhino came ashore at Omaha, as you can see here, with a load of 12 M4 Sherman tanks. This is over 400 tons. Leaving a freeboard at points of mere inches. 2 ferries struck mines, and enemy aircraft and artillery menaced operations, but the pontoons and the Seabees kept working. Meanwhile, at Gold, Juno, and Sword beaches, the British and Canadians found themselves confronting 100 LSTs still unloaded by D+1, with their operational Rhinos barely at 50%. The Rhino forces commenced 24-hour operations to try and meet the pressing supply demand. Omaha remained in shambles after the initial landings, with a total of only 4,581 tons of supplies landed by D+3, rather than the planned 8,000 tons daily. On June 7th, Admiral Sir Bertram Ramsay, Naval Commander-in-Chief of the Allied Expeditionary Force, authorized the beaching of LSTs at all but Omaha. The failure of the British Rhino force to unload the LSTs at Gold, Juno, and Sword played a significant role in this decision. But with the risk of enemy artillery in play at Omaha Beach, Rhino ferries and smaller craft carried the bulk of material ashore until June 10th, when Ramsay finally authorized the LSTs at Omaha to beach themselves. And thereafter, both the American and British Rhinos began serving as lighters for Liberty ships, where they proved ideal for the task. Now, the pontoon causeways arrived off Omaha and Utah beaches throughout June 7th. At Omaha, Seabees of CBD 1006 completed installation of Easterly Causeway No. 1 on June 11th. Beach examinations revealed a shorter length would be sufficient, so the Seabees doubled the causeway width, and the final assembly measured 28 by 1,456 feet in length, with blisters spaced approximately 300 feet apart. The same crew commenced installation of Westerly Causeway No. 2, completed on June 16th. At Utah Beach, a 2nd Construction Battalion 1006 detachment managed to install most of Easterly Causeway No. 1 on June 8th, with personnel and vehicles offloading on completed portions while the Seabees continued assembly. When finally completed on June 9th, this causeway measured 14 feet wide by 2,200 feet long, with 8 blisters. Now, Utah's Westerly Causeway No. 2 was operational by June 15th, and at Utah Beach, from June 6th through the 13th, 85% of all vehicles and cargo came ashore thanks to Laycock's pontoons, either on the ferries or by the causeways. Now, for the British, assembly of the causeways commenced on D+1, and additional sections, or sinkers, as the British records refer to them, arrived up to D+29. Now, in the course of the tows across the channel, 10 of the 2x30 sections, 6 pontoon blisters, and 1 tug were completely lost and never recovered. 7 causeways, which were later reduced to 6 actually, were constructed. And you can see these here marked on the maps as number 1, number 2, number 3, and so forth. But what the British ended up doing, unlike the Americans, is they would actually disassemble and reassemble and shift the causeways according to their needs. Now, causeway number 2 on Gold Beach was the first constructed, completed on D+10, and it measured 1,233 feet in length. Now, causeway number 1 on Gold Beach was actually finished on D+16 at 1,400 feet in length. Causeway number 3 at Gold Beach was the longest of any of them, measuring 2,817 feet long when finished on July 5th, and causeways 5th, 6th, and 7 on Juno Beach all individually measured over 2,000 feet in length. And those were completed on 8, 11, and 28 July, respectively. Causeway number 4 was the lone causeway on Sword Beach, and that was actually made up of pieces from causeway number 2, which was abandoned due to silting and cross currents, but then causeway number 4 in turn was dismantled again when the decision was made to land all personnel and vehicles on only Juno Beach. And as such, causeway number 7 then was comprised of the remains of causeways 2, 3, and 4. As if this isn't confusing enough to a historian reading all the records. Now, unlike the American causeways, the British would stagger their causeways for both 1 and 6. So instead of a continuous line of the sections, they actually kind of staggered them in a zigzag. And this was to avoid bad patches of beach. Only causeway number 7 featured a double width, like those causeways used at Omaha Beach. Now, as the causeways came into operation, other Seabees of the 25th Naval Construction Regiment worked furiously to install Mulberry A off Omaha Beach. Work commenced on June 7th, and on June 16th, LST 342 became the first vessel to unload one of the specialized Lobnet's pierheads. And you can see those, I don't know if you look at the map here, look a little bit to the right, you'll see where it says dog green, and you can see these 3 lines. The Lobnet's pierheads are actually located at the end of those lines. Now, together with the Rhino ferries and the causeways, Mulberry A furthered the acceleration of the buildup of men, vehicles, and supplies. By June 19th, the U.S. Navy reported landing 124,404 long tons of supplies, over 43,500 vehicles, and 332,269 personnel at Omaha and Utah Beach. Now, by comparison, over the same time period, the British and Canadian forces at Gold, Juno, and Sword Beaches landed 101,184 tons of supplies, 40,272 vehicles, and 160,189 personnel. Of this, Mulberry B, under construction at Gold Beach, had reported by June 19th of landing 11,200 tons of supplies and 1,600 personnel. That's it. But then Mother Nature struck back. From June 19th to the 22nd, a channel storm turned the Allied invasion beaches into steel junkyards. The morning light of June 23rd displayed Mulberry A in shattered disarray, and the beaches a jumble of ships and landing craft. Those Rhino ferries that were still operational were driven ashore by the storm and ended up smashing against the landing craft, turning them in turn into matchsticks. For the British at Gold and Sword Beaches, only 2 out of their 14 Rhinos which were operational before the storm were available for use afterwards. Other Rhinos, however, came online on the American beaches, but the majority of the British Rhinos, quite frankly, remained useless because they had destroyed their engines. The Seabees, however, wasted little time, and on the afternoon of June 23rd at Omaha Beach, the men managed to get 7 of their Rhinos, as well as Westerly Causeway No. 2, back into operation. At Utah Beach, 3 Rhinos resumed unloading Liberty ships, and the causeways were repaired and placed back into operation in the ensuing days. Because of the severe damage, SHAEF chose not to rebuild Mulberry A's floating piers and pierheads, and the harbor's salvageable elements were then transferred to Mulberry B. And Mulberry B survived the storm for a variety of factors, which notably the natural production of the Calvados shoals, shallower sands anchoring the outer perimeter walls, and differences in the placement of the actual breakwater structures. And unfortunately, I don't have a pretty picture here, so I just give you raw data. Operation Overlord and the accompanying naval component, Operation Neptune, made ample use of these Navy landing pontoons. It's difficult to obtain clear statistical data for the numbers of personnel, vehicles, and supplies moved by the American and British Rhino and Causeway forces. But what is known can be seen here on the slide before you. And notably, just one of the American causeways, which I could find specific data, moved the equivalent of practically the entire British causeway effort combined. Now, for the critical period of June 8th through the 16th, the rhinos at Omaha and Utah safely delivered 19,056 vehicles and over 65,000 tons of bulk cargo. Now, compared to Army figures, this equates to rhinos accounting for 66% of the bulk cargo at Omaha and 86% at Utah. The figures seem exceptionally high, considering the movement of supplies by the smaller Army ducks, which are able to carry 5,000 pounds apiece, as well as LCTs and the role of the causeways. But if the latter predominantly move vehicles and personnel, then perhaps the figures are not too far removed from reality. Now, in after-action reports, Rear Admiral Sir Philip Lewis Vian, naval commander of the Eastern Task Force, concluded, quote, that the Rhino ferries failed to carry out their planned function. But he did acknowledge the utility of these barges for unloading Liberty ships. The naval commanders for Force G and Force J spoke highly of the pontoon causeways, noting how they, quote, are the only method of landing troops, working parties, etc., dry-shod on a flat beach. Now, training was cited as a limiting factor for the causeways, as the structures were both insufficiently understood by the Royal Navy or the beach groups in the early stages of the operation. But more intriguingly, you sense an inter-service rivalry that played a tremendous factor, with the Royal Navy personnel ignoring the British Royal Engineers on underutilized causeways. But amusingly, the U.S. Navy's LCTs would eagerly unload at the British causeways. And one British report actually notes that it's, quote, probable that 2/3 of the landing craft who used the British causeways were American. Now, Colonel Eugene M. Caffey, who commanded the Army's 1st Special Engineer Brigade, reported that the pontoon causeways, quote, essentially doubled the vehicle landing capabilities of LCTs and Rhinos, and thus contributed materially to the success of the operation. These pontoon structures provided Allied forces with a reliable logistical capability throughout the establishment of the invasion beaches. The uninspiring Rhino ferries and the causeways capably transported personnel, supplies, and vehicles ashore 24 hours a day. The pontoon technology itself functioned flawlessly, a product of interwar planning, practical design, and 2.5 years of operational use. Perhaps unsurprisingly, the Americans, rather than the British, more efficiently utilized the pontoons and maximized the utility of this technology. And the explanation for this, as I mentioned previously, is arguably more a fault of training and institutional culture rather than the limitations of the pontoons themselves. Lamentably, not one of the 500,000 of these U.S. Navy pontoons exists today in an American military museum. And although they are forgotten, the pontoons arguably endeared themselves to the thousands of soldiers who came ashore of dry feet at the various invasion beaches, marching across steel roadways onto France in victory, thanks to the humble magic box of Captain John Noble Laycock. I thank you for your attention, and I will try to answer any questions to the best of my ability.
All right. Well, great. That was an amazing overview of Operations Husky and Overlord. I think this is one of the unsung parts of the war that most people don't really think about. They usually think about, going up against the Hornet's Nest, the machine guns and the explosions, but they don't think about, how you actually get there, how you get on the beach, how you resupply, how you sustain the fight, so to speak. So that was definitely an exciting discussion. So now what we would like to do, we have an opportunity to have some questions. So it was really, again, good to get so much detailed information. And I know there's already a couple of questions that have started to populate, and we want to make sure that there's time for that. I guess one of the things that also wanted to talk a little bit about was what actually got you interested in this kind of work? Not to kind of shift too much, but you've given so much information, you've written so much. So tell us a little bit about, what made you so interested in talking about pontoons and basically Navy lighterage?
Well, quite frankly, the interest arose during my time as a historian at the U.S. Navy Seabeam Museum, which was my first job out of graduate school. And while I was there, probably within the first week or two, familiarizing myself with the history of the Seabees, particularly their Second World War history, the pontoons are just a critical component of their story. And you see the pontoons discussed not just in the European theater, but their extensive use in the Pacific theater. And what was interesting to me was, as critical roles they played, we didn't have one in the museum. And that always had me curious, well, where are they? Where can you find one? Not to mention this fascinating story that Captain Laycock came up with the concept using cigar boxes. And I openly admit, I went on eBay trying to find a cigar box of the exact month and time and style that Captain Laycock would have used, because we didn't have the original model. We only had photographs of it. Now I'm going to fast forward to 2017. Within my first week at the Smithsonian, a colleague was taking me through some of the storage areas. And unfortunately, I hate to hurt the feelings of people, it's not like night at the museum. The artifacts don't come alive at night. Ben Stiller is not a security guard, and nor does it look like Raiders of the Lost Ark, where you have this giant warehouse of crates at the end. It to some extent looks like somebody's messy garage, but and now I've revealed the secret. Be that as it may, as I'm taking one of the storage rooms and they're moving the storage racks to show me some of the artifacts, my jaw drops, because here's this assemblage of cigar boxes. And I go, do you know what that is? Do you know what that is? And they go, actually, no, we don't know what it is. That's why we hired you. Tell us what it is. And I ran back to my computer and printed out a photograph and kind of held it up to the model. And it's it. It is the model. But nobody really, and you saw some of the other artifacts we have in the collection related to the technology. Long story short, Captain Laycock's estate donated these artifacts to the Smithsonian in about 1967, 1968. But it was totally forgotten, and the history was forgotten. So as a curator, as a historian and as a curator, to be able to take those material culture artifacts, but then combine them with the historian sensibilities to go into the records, what you soon discover is that this part of the story is basically forgotten. And I have some of the books here. You know, the Mulberry Harbors, there's actually several books about the mulberries. Craig Simon's outstanding work, Operation Neptune, does talk about the Rhino ferries, but that's all you know about. And furthering this story, the Royal Navy contribution, which I'm still working on, came about, quite frankly, because while reading about Laycock, you see this name, Hussey, and then you're going, well, Thomas Andrew Hussey, who's this guy? And doing a little more research, I came across records that there was a question that who really came up with the concept to develop the causeway? Who really came up with the concept to develop the ferry? The internet today is a tremendous resource. Using Google, I actually managed to track down one of Captain Hussey's sons, and he died in 1980, but I think he had 4 children, and I found his youngest son, and his youngest son was kind of flabbergasted any American had ever heard of his dad, much less knew about this story. Here's a man who is very good friends with Mountbatten, going all the way back to the First World War. And he was at Scapa Flow when the British Grand Fleet sailed in late 1918. He witnessed that. He fought as a destroyer captain in 39 and 40. In fact, his destroyer was almost sunk off Dunkirk, and he helped evacuate the Norwegian royal family before he came to combined operations. So this relationship between Hussey and Laycock is something that's just an untold story, but a really fascinating example of Allied interaction and Allied innovation of this mid-level manager that Paul Kennedy talks about. So pontoons are perhaps not a sexy piece of military technology, but they are an essential component of all of the amphibious operations, both in the European theater and particularly in the Pacific theater. That's a very long answer to a very short question, and I apologize.
But it actually fills in the gaps and definitely gets it to the heart of, I guess, what's motivated you through this, and you can definitely see the passion. And I guess the other thing, when you talk to modern day operational commanders, or even when you look at the history of World War II, they always talk about the fact that you can't fight a war without logistics, and this is just one of those pieces in the logistics chain and the line of operation and line of communication.
Absolutely.
So it's absolutely essential. We do have a question that came in from the audience. One of the questions that was asked is, were the pontoon assemblies designed or tested to withstand various sea states?
One information I have about that is yes and no. They were certainly tested in varying states for their strength to see what could they withstand. They were pressure tested. They were never intended to be pulled underwater. But what they quickly discovered is individual pontoons, like any flotation device, if you throw them out in various sea states, they're very durable and they will hold up. It's when you begin to construct them into the strings that they become a little more fragile, because the entire assembly then is a lot less seaworthy than you'd like. But the durability of the pontoons, one of the more enduring examples is from Guadalcanal, where the Navy would frequently make smaller assemblies, about 3x7, to move materials at night under the cover of darkness. One instance, they were moving a barge full of gasoline in big drums, and the Japanese attacked, hit it, set it afire. The Navy couldn't sink the damn thing, and they riddled it with every single weapon they had. They simply could not sink this barge because of its buoyancy. So I find it staggering that the British not only lost some of these, but we have no idea what became of them. So if anyone is, I'd love to know if with any of the archaeological studies they've done of the Normandy beachhead, if they ever find one of these things stuck on the bottom, because I'd be amazed if it actually managed to sink. Otherwise, it makes me wonder, where are these things? Is it frozen up in the Arctic or something? Because every report I have of the seaworthiness is, it's nauseating to ride them, but they're damn near impossible to sink and destroy. And again, very long answer. Sorry, Fred.
Okay. Well, I guess there was another a thought that I had is when you think about Navy lighterage today, or if you actually think about causeways today, I think the Military Sea Lift Command has a causeway. Well, the way you've described it, when they made them fixed, they would extend them out into the sea and then basically sink them, and then they would just be fixed based on their weight. But I think today they're actually using pylons.
Correct.
And using more of creating kind of like a bridge into the sea.
Yeah, and it's more of an elevated system than a sunken system. I mean, the technology Laycock developed it's not as sophisticated, quite frankly, as what we have today. But one could argue that it's also, I don't want to say idiot-proof, but there's a simplicity to it as well, a very fundamental simplicity to how they operate. And if anything, the P series of pontoons, which emerged during the 1950s in the Korean War, and there is one of those on display at the Seabee Museum, kept the exact same dimensions as Laycock's pontoon, 5x7x5. The only thing they really simplified were the jewelry, the actually mounting hardware. If anything, Laycock's design was more, it was not only overly complicated, but it was stronger than it needed to be. It's that assembly angle, essentially the steel kite sticks, if you will. That's really the key element to locking them all together. And of course, by the Vietnam War, you have the AMI pontoon come aboard, which is probably the closest relative to now the improved Navy lighterage systems that we're in use today. Although I have not studied all the successors to Laycock's pontoons. I mostly just stick with Laycock.
So. Okay. Yeah, because there is the difference between the floating lighterage and having a fixed causeway and the benefit. I mean, you described obviously going off of small floating vessels in offloading versus a large Liberty ship, and seeing the benefit depending on which type of craft was being offloaded.
Absolutely.
I guess, right. And we had another question that came up, and it said, is it correct to assume that in addition to tide and weather issues, German defenses were showering the Rhino ferries with fire of all calibers?
That is correct.
I guess just as an amplification, I guess normally when a lot of the logistics happen, it's usually when you could say that it's more of a friendly environment, but it looked like that they brought this in while the beaches were still hot.
The pontoon causeways really came under serious fire at Salerno and some at Sicily. So the Germans were not, this was not new to them. The barges were, but not the causeways. And as I mentioned, Lieutenant Olson was killed at Salerno, and causeways were bombed. The Luftwaffe would bomb and strafe them. At Normandy, they did have artillery fire. But again, the beauty of the pontoon system, it's cellular. So if you do have a damaged pontoon, they would essentially have guys come along with scrap steel and just weld patches, if you will, to the individual pontoons. Some units that were heavily damaged, particularly by the Teller mines, which were, and Saving Private Ryan has it completely wrong there, if you like your movie history. The asparagus of sorts on the beach did not point inward. It pointed this way. And so when the barges came over, they might ride over top of that Teller mine, but when they were retracting, they were hitting it and detonating it, which would blow the underside out of a pontoon and flood it. But what the Seabees could do is essentially, if they needed to, cut open the top of the pontoon, go down, weld a patch, cover it back up, or they could unbolt the individual units and remove them from the assembly and stick in a new pontoon. So again, this is where I think the British didn't have the technical expertise as the Seabees in repairing them. But the Seabees absolutely were able to salvage the pontoons, and there's plenty of stories of pontoons being used for any and everything outside of their military use. But they were very tough. I mean, understanding not just with German fire, but Japanese as well. The pontoons are fairly strong systems. I don't have the numbers in front of me, but if anyone wanted to know the steel thickness, I can even give you the exact steel thickness of these. They're very, very durable structures, which again, it's somewhat sad we don't have one of them left that I know of anywhere in the United States.
Okay, thanks for that. We also had another question. Is there a percentage loss of material from damage or the lost rhinos?
In terms of lost productivity, or
let's say percentage loss of material from damaged lost rhinos.
I don't know
probably the material that was being transported across.
Yeah, I have no evidence of loaded rhinos losing their cargoes. I've never come across any account of that. If the rhinos were lost, it was typically when they were unloaded. And the other thing is, when they sent the rhinos across the channel, they were unloaded. And so they were just towed. And imagine this, there's no cover for the crew. So if you want a real fun, reenacting experience, get aboard a flat pontoon structure and get towed across the English Channel in choppy seas, or in the early morning hours. I'm sure it's loads of fun for anybody who enjoys that sort of experience, and I get seasick very easily. But with that being said, I don't know of any account ever of a rhino losing its cargo. They, much less a causeway. They were able to fulfill that part of the mission. The losses are almost entirely due to the fact of either damage, loss of control, and particularly due to the channel storm. A lot of rhinos just got smashed into oblivion. If you saw in some of the photos on the slide, those massive outboard motors, which were the largest outboards ever built in world history at the time, you actually had to raise them up when the barge came up the shore, and then you would use tractors to pull the barge all the way up on the beach. Unfortunately, a lot of those motors were either damaged or knocked out of commission due to the beaching and the retraction procedures. And the British wiped out their motors very, very quickly, unfortunately. Now, they had rhino tugs, which were meant to kind of push and guide the rhino ferries. But if you can imagine this 175-foot, 40-some feet wide barge, it's not easily maneuverable. It doesn't have a rudder. You need tugs, and the tugs just add to the difficulty, particularly in choppy seas. But inside the Mulberry harbors, offloading the Liberty ships, the rhinos were incredibly effective because they had much smoother, calmer water. And they didn't have to go to the complicated process of essentially mating, bow to stern like that with the LST. They could just pull alongside a Liberty ship, and then they could use the crane to bring vehicles down.
Okay.
I'm clearly not giving short answers to anything. I apologize.
That's okay. And then someone had said that they'll probably contact you offline to get some more information about the thickness of the plates and those kind of details. I guess it's a construction engineer, a structural engineer or something is probably.
And I see a question here about motor horsepower. I want to, off the top of my head, I want to say it wasn't as great as one thinks, something like 120 horsepower. Long story, yes, I have those figures too. They were each controlled. There was one coxswain at each motor. And so this massive outboard had your tiny little wheel and your tiny little control panel kind of built in the side of it. And so you'd actually have two coxswains controlling each of the motors. Now, one of the confusing questions that I still am trying to resolve is the British early on, they took the designs of the Rhino from the tests at Narragansett and Davisville back in August of 43, took them back to England and said, that's what we're going to build. And one set of documents I found said that they did adapt and copy all the changes the Americans made, which included adding these two outboard motors. But they also used a huge number of the Rhino tugs, and it appears the Navy didn't. And the British were using the tugs to push the barges. So it's still not clear to me if all the British Rhinos were converted to use outboards, or if some of them didn't have outboards and they relied on the Rhino tugs to push them along. either way, they're very slow, and they're very slow. They're very ungainly, but the issue of beaching LSTs, it's not just an issue of enemy fire, but you damage every time you beach that LST. You're wearing thin the hull, the steel under the hull, and they're valuable ships. And Admiral King, as soon as Normandy and Dragoon was done, he needed those LSTs for the Pacific. So I'm sure I've never seen his take on the Rhino ferries or the causeways, but I'm sure he was probably a cheerleader of them as opposed to damaging or risking his LSTs.
Okay. Well, thanks so much for that. And you mentioned that there's no remaining causeway or a pontoon that we can look at now in any museum, or at least in the United States. But, as you said, this is kind of like as technology develops, things progress. And today, we have what's called the improved Navy lighterage system, which is the latest generation of this technology. And people that go out to Port Hueneme, California, or Little Creek amphibious base in Virginia might have an opportunity to see some of these lightering barges and lightering ferries in operation. And I also know sometimes there's some exercises where the elevated causeways are also put up if people are able, if they're in the Norfolk area at some point, they might even be able to see that. But it's been quite interesting. And you mentioned that there are museums, though, that you are at in Port Hueneme, and then obviously you're at the Smithsonian. Is there anything you can tell us about, what people could see or what they could look at if they just wanted more information or to see some kind of displays?
Absolutely. Well, if unfortunately the U.S. Navy Seabee Museum is currently closed due to the COVID-19, but when they reopen, you actually can see a P-series pontoon, which is 5x7x5, on display there at the museum, as well as models of LSTs and causeways and some of the early the pontoon training models. And for Fred, lots of information on those outboard motors, if you'd like that too. But on their website, and if you go to history.navy.mil, you can, I think, find a link there to the Seabee Museum. You'll find tons of information, photographs and articles too about the use of the pontoon technology, both in Europe and in the Pacific. Now, at the Smithsonian, we are hoping on September 18th to reopen the National Museum of American History on a limited basis. Unfortunately, our major military exhibition, The Price of Freedom, Americans at War, will predominantly be closed. And again, this is due to cleaning the exhibit areas to minimize any potential contamination or exposure. But we will have our Vietnam War section of Price of Freedom open, as well as our Medal of Honor displays. We're also going to have, people can see the front of the gunboat Philadelphia. It's the only surviving naval vessel from the Revolutionary War, built and lost in action in 1776. I believe raised in 1935 and came to the museum in 1961. So the gunboat Philadelphia is there on display. We also have a D-Day display, which yours truly had a hand in designing and curating, and that's also going to be available to members of the public. I believe we're going to use a ticketed system, and so please visit us at americanhistory.si.edu, and you should be able to find information about reopening procedures, and if you'd like to visit, to obtain tickets. There we go.
Okay, great. Well, again, thank you so much for everything that you've shared with us today, everything that you've been able to enlighten us with. It's certainly been one of those kind of discussions that, again, it's those little hidden gems of history that you really have to dig for to find. But once you find it, it's really amazing what you can do with it, especially, again, as you can see how the technology has developed over time. I really want to thank everybody who's online and who's been able to join us. Again, the Naval Order Continental Commandery is here to serve virtually all of our companions around the United States and around the world. So we're always asking for you to be with us and to join us and to find ways to share with us. So please feel free to go to our websites. We do have links to our YouTube channel and our Facebook channel. This will also be, it has been recorded and it will be posted. So you could also tell some of your friends and some of our other companions to look at that on the website. But once again, thanks so much to Frank Blazich and all of the great things that you've done. Doctor, you were definitely a wealth of knowledge And we really look forward to hopefully having you with us again. So thanks to everybody. Have a good evening and be safe.
Thank you very all.